Bismillahirrahmanirrahim. Assalamu alaikum student. Today we start exercise 2.8. In this exercise we study three series. First of all, power series, that is f of x is equal to a0 plus a1x plus a2x square plus a3x cube and so on. In general, we can write xn power into x power n. Maclaurin's series. In this exercise, we will study two basic series, Maclaurin series and the next is Taylor series. Both for the mathematicians. So here f of x is equal to f of 0 plus first derivative of 0 into x plus second derivative divided by 2 factorial x square and so on, third 0 divided by 3 factorial x cube plus so on. In general, we can write f power not exactly power, nth derivative of f of 0 divided by n factorial into x power n. This will be the general term. Here f of x plus h is equal to, if you want to write here general term, so that will be like this, but this is not power, this is nth derivative and it goes on infinite. Here f of x plus h is equal to f of x plus first derivative of x into h plus second derivative of x to h square divided by 2 factorial plus third derivative of x divided by 3 factorial into h cube and so on. So there is only small difference in this. What is h? H is a small increment. This is the only difference in this. Here we take 0. X is equal to 0 instead of. I solve the question, then you will be able to understand exactly what it is. He is saying in the question, apply the Maclaurin series expansion to prove that. This Maclaurin series is also known as Maclaurin theorem, but normally we say it Maclaurin series. Part 1, log of 1 plus x is equal to x minus x square by 2, x cube by 3, minus x4 by 4, plus so on. Let f of x is equal to log of 1 plus x. First derivative, what is the first derivative? 1 over 1 plus x. Second derivative, at least 2, 3, 4, x power 4 is there, so we take 3, 4 derivatives. So what is the derivative of this? Means it may be written as, you may also write it like this. So what is the derivative of this? 1 into 1 plus x power minus 2. Again, when you will derivate this 1 plus x here and here also, so you will get 1, there is no need to write that value. So 1 plus x power minus 2. So third derivative, that is minus minus plus 2, 1 plus x power minus 3, or if you write that value as it is. Fourth derivative, minus 6 into 1 plus x power minus 4, and it goes on. On the other hand, we take f of 0, log of 1 plus 0, that is log of 1 is equal to 0. First derivative of 0 is equal to 1 over 1 plus x, that is 1 by x, that is 1 only. F second derivative here, when you put 0 here, so it becomes again minus 1, 0, so 1 power minus 2 is 1, so minus 1. Third derivative, 2 into 1 plus 0. Here you may also write if you want to write, otherwise there is no need to write like this. But I am writing because of you people, so to know it better. Fourth, minus 6 into 1 plus 0 power minus 4, that is minus 6, and it goes on. Now, by Maclaurin series, f of x is equal to f of 0 plus f prime of 0 into x plus f double prime of 0 divided by 2 factorial x square 3 factorial x cube and so on. So putting the values here, f of 0, 0, first derivative value of 1 into x plus second derivative value minus 1 divided by 2 factorial means 2 into 1 x square plus third factorial f of 0, that is 2 divided by 3 into 2 into 1 x cube plus fourth minus 6 divided by 4 factorial 4 3 2 1 into x power 4 and so on. Now simplify it. So 0 x 1 minus 1 by 2 x square plus 2 and 2 cancel, so 1 over 3 x cube, 6 is here, so cancelled, so minus 1 by 4 x power 4 plus so on. So which is exactly the given. So what is f of x? This is f of x value. So f of x is log of 1 plus x, hence proved. So this is what we wanted to prove. Simple wording, that whatever the given is value, we take it as f of x, derivate 3-4 times and put x is equal to 0. So we get this value. And then Maclaurin series says that f of x is equal to f of 0 plus first derivative of 0 into x into second derivative of 0 divided by 2 factorial into x square and so on. Likewise, we put all the values and simplify within 1 or 2 steps. So we get the answer. I solve one more question from this exercise, from this question number 1. Okay, one question I solved, cos x, second part. Cos x is equal to 1 minus x square by 2 plus x 2 factorial divided by 4 factorial plus so on. I take it as is. So this is the proof. Let question starts from here. Cos x and f of 0 is equal to cos 0 is equal to what? That is 1. First derivative, that is minus sin x. So, first derivative of 0, so minus sin into 0, that is 0. Second derivative, minus cos x, so second derivative minus cos into 0, that is minus 1. Third derivative, that is sin x sin 0, that is 0. Fourth derivative, that is cos x, cos of 0 is equal to 1, and it goes on. So 3-4 derivatives we are taking here. Now by Maclaurin series we get f of x is equal to f of 0 plus f prime of 0 2 factorial x, f prime of 0 into x, f double prime of 0 2 factorial x square, f triple prime of 0 3 factorial x cube, and so on. By putting the values, this implies that f of x is cos x, that is f of 0 plus first derivative 0 into x plus second derivative of 0, that is minus 1 divided by 2 into 1, 2 factorial x square, 2 factorial if we write as it is. So third 0 divided by 3 factorial x cube plus fourth 1 divided by 4 factorial x4 plus so on. So write it as it is. So 1 0 minus x square by 2 factorial plus 0 plus x4 by 4 factorial plus so on. That is exactly is equal to this one. Factorial may be written in both the ways, 2 factorial or this way. You have studied in first year class this factorial. So factorial you may write in this form, or if you want to write in this form, that is also acceptable, no issue in that. So I solve one more. Now I solve the second question. Question number 2, he is saying show that again cos x plus h is equal to cos x minus h sin x minus h square 2 factorial cos x plus h cube 3 factorial sin x plus so on, where he is saying that evaluate cos 61 degree. Let here cos x plus h is there, so we suppose f of x plus h is equal to cos x plus h, or f of x is equal to cos x. Derivate this value one by one. F of x prime of x is equal to minus sin x, first derivative. Second derivative of this minus cos x. Third derivative of this sin x. Fourth derivative of this cos x, and so on. So we are taking only 4 derivatives. Now by Taylor series Why we are not using Maclaurin? Because it is given cos of x is equal to x plus h, and Taylor series says that f of x plus h is equal to f of x plus first derivative of x into h plus second derivative of x 2 factorial, I write it in this form, h square plus third derivative of x 3 factorial h cube and so on. So putting the values here, so it becomes x cos plus h, f of x cos x plus first derivative minus sin x into h plus second derivative minus cos x divided by 2 factorial h square plus third sin x divided by 3 factorial h cube plus cos x fourth factorial x power 4 and so on. Or if I write it in a sequence in a proper manner, so minus h sin x minus h square by 2 factorial into cos x plus h cube 3 factorial sin x h power 4 factorial cos x plus so on. So this is exactly the given what he is asking the question, show that. So it is proved, but the second part is also there, that evaluate this same for cos 61. For cos 61, putting x is equal to 60 degree and h is equal to 1 degree, because h is a small increment, a small value. So we suppose x is equal to 60 degree, and that is the value which we have, easily we can find. H is equal to 1 degree, and 1 degree we know that is equal to 0.01745 or something, whatever the value may be. But here we put the value cos 60 plus 1 degree is equal to cos 60 degree minus h 1 degree, it is degree not one value, sin 60 degree minus h 1 degree square divided by 2 factorial into cos 60 plus 1 degree whole cube divided by 3 factorial sin 60 plus so on. So evaluate these values for 2, 3 values, only 3 values are more than enough. Take these values, simplify it, and you will get the answer. Cos 60 value is 0.5. Cos 60 is 0.5 minus that is 1 degree 0.0174, and cos sin 160 sin 60 sin 0.866 minus 0.0174 whole square divided by 2 into 1, cos 60 means 0.5. Only take these 3 values because these are more than enough. Square, you will take higher value, that will be decreased than this one. So here smaller than this one, so no need to. If I write 0.5 minus 0.01745 into 0.866 minus 0.0174 square into 0.5 divided by 2 So answer we have 0.5 minus 0.174. That is around 0.5000001, something like this. But whatever the value may be, calculate and try to do it yourself and check what is the answer exactly it is. So this is the way how to solve the values by using Maclaurin series and Taylor series. Power series we use to derive these two series, Maclaurin series and Taylor series. So try to solve these questions. If you feel any problem, so you may do contact with me. So inshallah I will try to solve your problem. Thank you very much.